Hello. Today we're doing assignment and lesson 28, something called dihybrid crosses. Now, I want you to know that this is a bonus assignment. There's nothing to hand in on this one. But this isn't something that I could really do. It's kind of like doing a microscope lab. It's a little too complicated to do online necessarily. So what I'm going to do, so I'm just checking that's rolling. It's a little too complicated to do online. So what I'm going to do is just show you what a dihybrid cross is, because when you get into grade 11 and 12 bio, if you take those courses, you'll need to catch up on this. This is something you'll have to tell the teacher. We didn't really do dihybrid crosses that much in grade 9 because of the whole situation this year. But I do want to give you a look at it, and I've given you some sheets in your booklet with answers. So if you want to practice it and get comfortable with it, you can. So I'm just going to do an example. Now, this is the sheet for dihybrid crosses. So what you would do is you would look at this sheet, and I give you the answers there. And then there's these dihybrid cross practice questions, and there's a worksheet with answers on it, right? And that's just for you to try on your own. You do not have to submit these. You do not have to do them. You don't even have to look at it. This would be the hardest thing you do in this entire unit. So don't stress if you're not understanding this, because this is something really that you have to do with the teacher in the room to kind of work through it. So I'm just exposing you to this today. So these would be the sheets you would do. And then once you got up to the sheet that was called pedigree analysis, that's where you would stop. So let's go to the dihybrid crosses. I'm going to mute the projector, and I'm going to show you kind of what to do here. So the first thing to know is, what does a dihybrid cross mean? Well, what you need to know is normally we're just doing a monohybrid cross, which means we're just looking for one trait. Say I was looking for a seed color where yellow was dominant over green. So say I had one plant that was big Y and the other one was little y, and I wanted to cross it with another plant that was big Y and little y, right? So this was a yellow parent hybrid and a yellow. Now, how many traits are we looking for in the offsprings? We're just looking to see what color these peas are going to be, right? So we're going with a yellow plant over, and we're crossing it with another hybrid yellow plant. I'm just going to put a little thing like this to let you know which ones are big Y and which one's little y. So all we're looking for is color. And say on this plant as well, we also studied later, and we were seeing if we were going to cross, say, a tall plant, or what did they use in this one? R. Well, I'll use R then, because that's what they use in the example. So we're going to do round seeds versus wrinkled, and round is dominant. So say we crossed these two plants. Like this. And so we had a round parent hybrid with a round hybrid parent, and we cross them. So we would also we'd get something like this, right? And here it would be the same thing. Right? That's great. That's what we've been doing so far. This square looks at one thing. It looks at whether it's yellow or green. This square looks at one thing, whether the seeds are round or wrinkled. Okay, that's cool and all. But sometimes you want to cross two traits at the same time. Say I have a plant that is yellow and round, and I cross it with a plant that is yellow and round. This is where a dihybrid cross becomes useful. Now, it's complicated, but let's look at the parents. So I'm going to take two parents. So parent 1 and parent 2, and now they're going to be the same. So I'm going to have parent 1 is going to be right? It's going to be a round parent with yellow seeds, and parent 2 is going to be the same. Okay, not bad. Now, how could we cross these all in one big chart? That's where a dihybrid crosses comes in. So what you have to do first of all is you have to make, instead of making just a little square like this, right, a little 4x4 square, you have to make a 16 square one. So you have to go And now you're going to put every combination of parent 1 and so you're going to put every combination of parent 2 here and every possible combination of parent 1 here, and then you're going to cross them. So let's take a look at this. Well, how do you find out all the combinations that this parent could make? Do you remember in math there's something called FOIL? Well, first, outside, inside, last. That's what FOIL stands for. So what you would do is you'd make a list of all the combinations that this parent can make. This parent could give a big R with a big Y, or it could give a big R with a little y. So I'd write combination option, big R, big Y would be one combination. Another combination that could have made would be a big R compared with a little y. Okay. It also could make a little r with a big Y and a little r with a little y. So those are the 4 combinations, crossing this one with that, and then this with that, and writing them down. And then this one with that, and this one with that. And I've written them down. So what I do is I put parent 1 here. So I could put big R, big Y as one parent. Big R, little y. Little r, big Y. And little r, little y. And that's every combination that parent 1 could give. Well, parent 2, what are the combinations parent 2 could give? Well, in this instance, it's pretty easy because they're the same. So I can literally just write the same things for parent 1. I can put parent 2 down here because it would be big R, big Y, big R, little y, little r, little, big Y, little r, little y. So I could do the same thing. Now all I have to do is fill out the chart. And it's a little complicated, but let's see if we can do it. This one would be big R, big R, big Y, big Y. All right. This one would be big R, big R, big Y, little y. Okay. Big R, little r. Big Y, big Y. Big R, big Y, little y. Oh, I made a mistake there, sorry. I would do the same thing here. I would cross them in. Big R, big Y, little y. Big R, little y, little y. Big R, big Y, little y. Big R, little y, little y. And so on. I just switched that order there, but that's okay. Always put the big letter first. There you go. And that's how you would do a dihybrid cross. Now you could look at the practice sheet. You could see down here, there's the answers for the first one. And you can see how many of each. So you would say, okay, this one is round and yellow, hybrid. Is there any other ones like that? Oh, round and yellow, hybrid. So there's 1, 2 like that, right? How many are all purebred recessive, weak? Just that one. Look at that one. That's the only one that's going to be dominant, 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 dominant. And you could start breaking it down by genotype and phenotype if you're feeling really nerdy. Now, I want you to just go here and take a look. There would be more examples with answers for you if you really felt like working on this some more. You could try these word problems on the page before. And you could also try working along with these to see if they make sense. And of course, a couple more word problems. Like I said, this is just something that if you're really keen on science and you really want to do, this is a great lesson for you to work on. Dihybrid crossing, where you're not looking for just one trait, whether it's round or yellow. You're going round and yellow, parent 1 crossed with parent 2, and you're doing it all at once and making this 16 square Punnett square. You only use this when you're when you're comparing two traits from parents at the same time. That's why it's called di, because di means two, dihybrid cross. So you're crossing two traits to see what could possibly happen. So I hope this is kind of interesting and weird. When you get to the part for the dihybrid cross on the review, you don't need to do it. You can leave it blank. I'll try and warn you about that, but if you want to give it a try, feel free. This is, like I said, the most advanced thing, and I've given you notes with answers that walk you through it. It's not a very easy thing to explain like this. It's better if you're in person. So I didn't make this a required assignment, but it's something I want you to have exposure to, because you will be using this again in grade 11 and 12, and you're probably going to have to do a catch-up lesson on it or do some work on your own in a couple years when you get back to this assignment later. So coming up next, we're going to look at pedigrees, and then we're going to look at sex-linked traits, and then we are moving on to the review. So be safe. We'll see you soon.